Greetings and welcome to the Engineering Design Highlight Promotional Video, acronym ED. At any point to reference our presentation, please take a moment to go through and input this HTTP bit.ly code within your web browser to follow along with the presentation and to access resources. We will be covering presenter information, engineering design overall, discussing the new standards for technological and engineering literacy, our 6E Learning by Design model, which is for our lesson plans, how this fits within the pre-K to 12 sequence of learning and our standards based on the core, some coursework examples, how to navigate the course on our LMS or our media-rich version, and the standard edition, which is a PDF, some other information on cost, as well as information. This presentation is presented by Ryan Novitsky, the ITEA STEM Center for Teaching and Learning Director of Learning. If at any point you have any questions, comments, or concerns, please feel free to reach out to that email provided at any time. Engineering design focuses on how engineers apply their creativity, resourcefulness, mathematical, scientific, and technical knowledge and skills in the creation and refinement of technological products and systems. The overarching goal of this course is to gear the students towards developing a final product in the 4th unit that is a culmination of all the learnings throughout this course and prior courses to develop a product that has never been developed before or an innovation or inventive standpoint. It is intended for grades 11 to 12, recommended to take Foundations of Technology in one advanced course before taking engineering design over a 36-week span. The 4 units are Fundamentals of Design Engineering, Elements of Design, Structural Design, Product and Systems Engineering and Analysis Management. Units do build upon one another, so it is recommended you teach Unit 1 first, leading up towards Unit 4 being last. Engineering design has an at-a-glance, and if you were to left-click on this presentation and go into at-a-glance, it helps provide a summation of each of the 4 individual units, course length, and the intended audience. So if you take the bit.ly code from the presentation, you'll be able to go in the presentation and left click on the ED at a glance for that further informational standpoint. There are big ideas and learning cycles within engineering design, which we'll cover a little more in detail in this presentation. Big ideas provide an objective for the intended learning for the student to master at the end of a lesson. The learning cycles are within each unit, and they help to build upon the learnings from the prior units of learning cycles towards a mastery of their overall content standards within that given unit. Also, embedded with our presentation are 3 different resources that help to describe our newly revised standards, the Standards for Technological and Engineering Literacy. The former Standards for Technological Literacy have been innovated and launched the Standards for Technological and Engineering Literacy in 2020. These standards, amidst other national standards, drive all of the Engineering by Design content pre-K-12. Take a moment to click on the presentation as far as resources within the provided presentation. Engineering design has lesson plans within their learning cycles. The learning cycles are built off of our 6E Learning by Design: engage, explore, explain, engineer, enrich, and evaluate. We focus on developing the little e in engineer, not the big E, referring to we want students to have the knowledge and skills of problem solving and analytical thinking to be able to solve everyday problems. Our lesson plans within our learning cycles follow the 6E format to help the teacher to teach the individual lessons. Engineering design is our 11 to 12 course as far as the grades and falls at the end of our sequence of learning for our K through 12 base standards. We offer pre-K to 12, but it is not to say that you have to take the middle school courses in order to be successful to take the high school or elementary fitting in a middle school. It is recommended. And remember, as mentioned before, it is highly recommended to take Foundations of Technology and at least one advanced course prior to taking the capstone course to ensure the students have the content, knowledge, background to be successful in taking engineering design. We have some coursework examples listed within here, and we're also going to go through and navigate the media-rich edition on the next coursework example. Unit 1, Fundamentals of Design Engineering, helps to focus overall on students learning how to use scaling appropriately, ergonomics, and different areas that focus on human factors, industrial factors affecting design, and other areas as well too, in order for students to understand how to develop an effective product based around particular needs. If you're in this presentation, you could take the moment to also left click on resources, which will bring you to PowerPoints, lessons, and activities embed directly within Unit 1, Learning Cycle 1. Another coursework example is Unit 2, Elements of Design. Specifically, Unit 2, Learning Cycle 2, what's the problem? The overarching big idea for this individual learning cycle is robot design always includes requirements that require trade-offs. As mentioned before, we included the resources within this presentation to check out the entire learning cycle with the PowerPoints, activities, and documents embed within this specific learning cycle. At the end of this learning cycle, the students will understand how to program a robot to run autonomously as well as manually, and they'll begin to understand a deeper understanding of taking core technologies and mathematical calculations to then key turn them into making a product which is a robot to do a specific task. To navigate to the coursework overall, if you go to ita.org and you left click on EbD Buzz and you log into EbD Buzz portal, you're going to want to make sure you click on your engineering design course. When you get to your engineering design course, you'll notice these arrows, these little carrots. When you left click on it, it scrolls down and back up and brings submenus and menus back and forth and down. Let's focus on Unit 2, Learning Cycle 2. As mentioned before, the lesson plan is in a 6E format that has engage, explore, explain, engineer, enrich, and evaluate that helps the educator to instruct the students effectively towards mastery of the content. The resources and supplementing files are built within here, as well as assessment and interactive quizzes, your overarching learning objectives, what to do to be effective in the lab or classroom to prepare for it, and your overarching standards and benchmarks which help to drive your content overall. And it also provides a lesson overview as far as what is going to be taught within the lesson within a shortened 6E format, as well as learning cycle duration, knowledge, skills, purposes, big ideas, and your overview for students to understand how to utilize a variety of simple and complex technologies, which in this learning cycle helps to go through and fulfill a problem, which is designing a robot to do a particular task. And as mentioned before, when you left click on the resources for Unit 2, Learning Cycle 2 in the presentation, they're all located in here for you to kind of go through and check out at your earliest convenience. In order to navigate to the MediaBridge edition, we just showed how to go through and navigate to it in regards to the EbD Buzz version. And as far as the standard edition, when you go to ita.org's website to get to our PDF version, you left click on eStore, Product Catalog, and then you simply afterwards type in the name of what you're searching for overall in the product catalog to get there. And then you're able to download it. If you are a consortium state, you do not need to pay for this. It is a free of download. But if you are not a consortium state and you're a member of ITA, it's $75 for the full PDF version or $95 for a non-member overall as well too. So that gives you PDF version, but does not give you the interactiveness of the learning management system through our Buzz portal, which allows you to do data analysis, inputting students, as well as additional content to make your course fit the needs of your classroom. Well, what is the cost of EbD? Please take a moment to look at the cost of EbD specifically towards the state of Minnesota below. And once you've done that, for more information to access the coursework, content, etc. in the state of Minnesota, please click on the MN Engineering by Design website and feel free to reach out to Minnesota EbD State Consortium Director Mike Sandell at any time. Thank you and have a wonderful year.